The following is a paid program brought to you by IrriUp LLC. Are you tired of sitting at a computer screen for 8 hours a day?
I'm so tired of working behind this computer screen for 8 hours a day.
Do you long for the great outdoors while you're trapped at work? Does your cubicle feel more like a jail cell?
I feel like I'm trapped in this cubicle.
Well, now there's help for you and for all Pennsylvanians who are longing for the benefits of nature. Introducing IrriUp.
IrriUp is an automated plant watering system meant to incorporate agriculture, engineering, and computer science to improve infrastructure, mental health, and nutrition.
We followed an engineering design process when constructing the IrriUp product and its supporting components. The first step of our design process was to define the problem our product was aiming to address. One of the main issues the IrriUp targets is the lack of green space and sustainability present in Pennsylvania. Pennsylvania is a state that especially struggles with demolishing unused infrastructure and preserving current green space. To combat this, the 2030 Green Space Network goal is a project taken upon by the Delaware Valley Regional Planning Commission. The goal is to protect as much green space as possible in Pennsylvania and New Jersey, as well as create new green spaces. According to the DVRPC, there is currently around 200,000 acres of unprotected green space network lands in Pennsylvania, which indicates that there is still a lot of progress that has to be made to achieve the 2030 Green Space Network goal. Additionally, only 26.9% of current green space is protected. By creating a product that converts old infrastructure into new green space, Pennsylvania will become more successful at attaining the 2030 Green Space Network goal. According to a study conducted by Professor Hardig from Uppsala University, green space can provide mental health benefits and possibly lower the risk of psychiatric disorders. This nationwide study, covering over 900,000 people, shows that children who grew up with the lowest levels of green space had up to 55% higher risk of developing a psychiatric disorder, independent from effects of other known risk factors. This shows the correlation between green space and mental health, which leads us to the next problem the IrriUp aims to address.
While mental illness has been an increasing issue in Pennsylvania for years, the pandemic has amplified this problem by a factor of nearly 2, with Mental Health America observing a 92% increase in people seeking help with depression since January of 2020. This trend is the result of many factors like unemployment, isolation, and more, so it cannot be addressed at the root cause. Instead, we aim to resolve the issue by ameliorating mental illness itself. Since past research has shown that greenification is an effective way of achieving this, we decided that a portable and cost-efficient autonomous gardening device would be successful in improving Pennsylvanians' mental health in addition to several other issues.
Our first local business connection was with a mental health expert and therapist in the Wyomissing area, Mrs. Michelle Chrisman. When inquiring about whether placing a product like the IrriUp in a stressful company environment would help with reducing stress in the workplace, Mrs. Chrisman stated that having plants in a corporate environment could definitely help to reduce stress and help with productivity and mood in the office. Especially due to deteriorating mental health issues because of limited social contact due to the pandemic, Mrs. Chrisman stated that focusing on positive coping skills such as growing plants in your environment would be very helpful. Additionally, Mrs. Chrisman suggested adding a feature to connect with others through the app regarding plant growth progress to bolster mental health even more and combat against social isolation. She also suggested adding an educational component to the app to show the importance of mental health and its effect on one's mood. We will certainly take into account this insight when approaching possible improvements to our product.
According to the CDC, most Americans do not have a healthy diet. 10% of Americans do not eat enough vegetables, 90% eat too much sodium, and over 50% drink at least one sugary drink per day. This is especially concerning because unhealthy eating and poor nutritional health can lead to susceptibility to obesity, cancer, heart disease, stroke, and diabetes, among many other complications. Even more concerning is the nutritional health of students in the COVID-19 pandemic. According to Tamika Anderson, the COVID-19 pandemic has severely damaged nutritional health among students. The lack of free or reduced cost school lunches for partially or fully virtual schools has negatively impacted the nutritional health of students who rely on these lunches, particularly those of lower socioeconomic classes. Therefore, a solution is needed to provide cheap and nutritious food sources for students in need.
When generating concept ideas for our project, we had several initial approaches. For the product, we wanted to incorporate ingenuity while also utilizing multiple forms of agricultural technology. Some of these include hydroponic technology, incorporating building pillars into vertical gardens, portable greenhouses, and LED indicators meant to inform users when to water plants throughout the day.
Before constructing our first prototype, each team member created a concept sketch, and the best elements of each were combined for the final design. As you can see, the sketch on the left has the modular two-sided design, the one in the middle uses the horizontally oriented tubing, and the one on the right includes the water tank at the top, which eliminates the need for a pump.
Our initial prototype consisted of a PVC pipe frame with aquarium tubing and used recycled juice bottles as the water tank. Aquarium tubing ran vertically down the felt pouches, resulting in decreasing water pressure for pouches that were lower on the frame. To hold pouches up, we used a wooden dowel that was mounted on the PVC through a drilled hole. Our prototype served as a model and a proof of concept for the final product, where we could fix the mistakes we made in the first prototype, while also polishing and finalizing the design of the product. After conducting some tests, we decided that running the aquarium tubing horizontally rather than vertically would be the best way to equalize the water pressure among all plants. A separate tube was included for each row. The water tank was also improved to a recycled acrylic tank that could hold water much more efficiently while also being more visually appealing to the user. The PVC frame worked well, so we decided to use a similar design for our final product. For additional stability, we included some cross beams and diagonal supports in our wooden frame. Instead of the dowels, we decided to use hooks to hang the felt pouches to increase modularity by allowing the swapping of different tubes and types of pouches. Our final product also had the addition of the electrical components to control the automated irrigation. These parts consisted of the Arduino, a custom-built Arduino shield, LED lights for aesthetic purposes, servo motors to open and close the water flow, extension cables to plug in multiple components, a power supply to draw electricity from outlets, and an Alexa smart plug to allow for voice-activated watering of plants. We also included a companion app which included Bluetooth technology to enhance the user experience and improve functionality of the product.
As we constructed both of our prototypes, we divided the process into 4 main steps. First, we designed an app using MIT App Inventor that could interface with an Arduino via a Bluetooth module. Next, we programmed the Arduino and soldered the necessary components together before fitting them in a watertight box. After the electronics were ready, we constructed the frame of the device. This process differed for the 2 prototypes because the first was made of PVC and the second was made of wood, but we followed designs that we had made in Autodesk Fusion 360 for both. Finally, we assembled the electronics, tubing, and water tank on the frame. This was the most difficult part, as the valves had to be mounted with extreme precision in order to properly start and stop the flow of water.
After the completion of steps 1 and 2, we started with constructing the frame. The wooden frame was assembled from recycled wood and miscellaneous construction elements like screws, brackets, and hooks for rigidity and durability. The watertight container securely fastened to the top of the product was designed in Autodesk Fusion 360 from scrap acrylic using a laser cutter. With this tool, we were able to incorporate our logo to better promote IrriUp. After finishing the construction of the frame, we began assembling all other components. The Bluetooth module that had previously been installed in steps 1 and 2 utilizes micro servos, aquarium tubing, and valves to allow for user-specified control of water flow.
Our product is intended to be in both private and public green spaces, so it is important that the average person knows how to use it. Therefore, we include signage that can be displayed on the product itself, explaining how to use the app and connect to the IrriUp system. As the product is intended to improve mental health, it is important that the product is visually appealing to ensure a pleasant user experience. Therefore, we also finished the wood by staining it, which would serve a double purpose to seal the wood and make it waterproof, and added LED lights to light up the water tank. These visual improvements make IrriUp much more appealing, and they entice users to take a mental health break. while also adding an ambient calming effect when people are nearby. Finally, we add an Alexa smart plug to make the product as easy to use as possible. This way, all someone has to do to take a mental health break is speak a verbal command, making the process very easy and efficient. It may seem like a small improvement, but even just a little ease of use can go a long way when it comes to mental health.
The scale of our project meant we needed weeks to test and refine our product. We suffered from multiple problems with various elements of the IrriUp, including the microservers. In order to remedy this problem, we went through a painstaking process of precisely mounting the servos and valves to allow for proper rotation. Additionally, we suffered from leakage in our water tank. Considering the importance of this component to the project as a whole, we urgently tested multiple sealants in order to eliminate any possible leakages. Through trial and error and weeks of troubleshooting, we were able to solve these important issues as well as other small logistical errors.
After testing our product, we were able to effectively evaluate our solution. Some aspects of our solution that were successful was that we were able to create an automated plant watering system with a corresponding app that establishes an environment for plants to healthily grow. Additionally, we were able to address our initial problems through incorporating calming aspects to the product, like the visually appealing lighting for mental health. Some limitations to our current solution are that there isn't an individual servo control and there's minor water drippage during usage. Additionally, the app is more compatible toward Android devices. Lastly, the size of plants able to be grown and the limited plant capacity makes it difficult to mass-produce plants for nutritional health. Our second local business connection was with Neopart Transit LLC, a local bus part transit company that is in a location where there is not as much green space in the corporate environment. When interviewing Mrs. Gretchen Merkel, the senior accountant at Neopart, Mrs. Merkel stated that having a plant system in the work environment would definitely make it less stressful, and that it can definitely be really visually appealing to work next to. Quoting her precisely, "I would love to have an IrriUp right next to my desk." However, when discussing the feasibility of having a product like the IrriUp in the work environment, she said that it depends on what the business is. For example, Neopart Transit is connected to a warehouse where a lot of workers are around a lot of dust and other metallic bus parts, so this may not be the ideal environment for the IrriUp. So the product would only work in certain areas of the office and it would need to be extremely neat and self-maintained. The IrriUp addresses this potential concern as it is completely self-automated and doesn't require a lot of maintenance or additional space and cleanup.
Currently, IrriUp has a unit price of $154. The device's components are relatively inexpensive except for the electronics, which consist of the Arduino, power supply system, and smart plug. While it is expensive, it is not significantly more than what the average family spends at the grocery store, and it will save an immense amount of money over time by enabling families to pay for seeds instead of fully grown food. Because of this, it would be a worthwhile investment for nearly everyone, regardless of their financial situation. Once IrriUp enters mass production, the unit price will be reduced dramatically. Even in initial production runs of approximately 100 units, the price can be reduced by nearly $30. However, even more significant savings will be achieved once full-scale mass production is implemented, with a final unit price of just over $90. Since the device primarily consists of simple materials like wood and acrylic, the price can be drastically reduced by purchasing materials in bulk. The cost of the electronic components is also significantly reduced, but to a lesser extent because the Arduino is not sold in bulk. The device can also be assembled relatively easily, so no parts of the manufacturing process will hinder IrriUp's scalability. Once full-scale mass production is achieved, we will have reduced the price by over 40%. This will save nearly $65,000 per 1,000 units. Because of the low price of the mass-produced device, it can be sold at a reasonable market price of $99 with a 10% profit margin. These profits will then be reinvested into the product to conduct further research and development, which will hopefully make the device even more affordable for the general public.
In order to write the sketch for the Arduino Uno, we used the official Arduino IDE environment. This was a multi-stage process because we evaluated different options for controlling the servos. We settled on using a hardware modification method,
for connecting the servos to the Arduino. This was done by creating a custom PCB that includes 6 sets of 3 header pins, the HC05 Bluetooth module, and power supply hookups. This board fits neatly on top of the Arduino, allowing for a tight fit. The board is then housed next to the power supply inside the box. 3-channel DuPont extension cables are then connected to the header pins on the custom PCB and pushed through an opening on the top of the plastic box. These extension cables are then what connect into each of the servos. In order to create the app, we used the MIT App Inventor IDE. This allowed us to create a clean user interface while still allowing for easy access to different components. In order to allow the app to connect to the Arduino, the Bluetooth Low Energy extension was used. In order to send a command from the app to the Arduino, this Bluetooth extension connects the 2 devices via a list picker. Either a 1 or 0 is transmitted, telling the device to turn on or off respectively with the push of a button. This simple command allows the IrriUp to be controlled from up to 45 feet away with extremely low latency. In addition to the technical components already listed, an adhesive LED strip was attached. This device is separate from the rest of the control system and hence has its own remote for controlling the lights. In order to water the plants effectively, a gravity-fed irrigation system was utilized. When the Arduino receives the command, the servos turn the valves, allowing water to come through from the water tank at the top. These then flow into Y splitters, where one end of the splitter goes to the row on the front side, and the other end goes to a row on the back side. Each row is controlled by 1 servo. Alrighty, so this is the interior system of the IrriUp. As you can see, we have safety pins to apply the irrigation system and vanes to the back of this. The water runs from here into each of these pipes, which is connected to each spigot for the pouches. In here is the AC to DC power supply and the Arduino, which are connected through an extension cable out to the Alexa Smart Plug. Those connect to the servos up here, the LED strip on a separate cable, and that's pretty much how it works. Alright, so now that we are at the IrriUp, the first thing that we need to do is access the Amazon Alexa Assistant through either your smart device or a smart speaker. So, now that we've done that, we can say, Alexa, turn my IrriUp on.
Okay.
And as you can see, the IrriUp is now activated. The next thing that you'll need to do is put the water in the system. The next thing you'll need to do is you'll need to open your smartphone and go to the IrriUp. Now that it's on, you'll have to select Water Plants to control the system. Click Scan and click DSD Tech HC05. This is the Bluetooth module on the IrriUp. Now that it's connected, you'll see 2 buttons, Valves On and Valves Off. To turn the valves on, simply hit the Valves On button like so. As you can see, water has begun to flow through the system. When you've determined that the plants have had enough water, simply hit Valves Off. And the water will stop. You can then disconnect and go to the home menu. Now that we've seen how the IrriUp waters its plants, we can check out some other features. In this case, let's take a look at the plant guide. As you can see, this plant guide streams the website growherbs.info to your phone. Please read the disclaimer on your screen now. As you can see, we can select a category such as all herbs, all vegetables, all greens, and all tea herbs. Let's pick all vegetables. We can pick broccoli, for instance, and that will give us information such as the growing notes, maintaining guide, and harvesting guide. Let's look at maintaining. Sometimes it takes a little extra time to load. Let's try another vegetable, such as butternut squash. Click Maintaining, and as you can see, it shows the instructions for when you should grow the squash and where. Now that we've taken a look at the plant guide, we can take a look at our mental health journal. Simply hit the journal button, and our integrated Google form will stream to your phone. Here you can reflect about your time after using the IrriUp to track your progress with improving your mental health. Just hit the home menu button, and in the future there will be more notification options in settings, as seen here. Currently we have an activity reminder, but it's non-functional due to the MIT App Inventor's IDE policy with sending push.
Thanks for taking the time to watch your presentation. We hope you enjoyed learning about our system, the IrriUp. Bye!